Good morning guys, and what we're going to look at today in our second tutorial on the cosine rule is applying it to real life problems. So remember, we looked at the cosine rule and the sine rule, which are on page 16 of our log tables, and this is where we have to try and intermingle the two. So the sine rule is usually a over the sine of a is equal to b over the sine of b. My cosine rule we know is a squared is equal to b squared plus c squared minus 2bc cos of a. And I know these are the main tools in my toolbox because I'm looking at dealing with a non-right angle triangle. So let's read the problem here. A vertical pole AC stands on a hill inclined at an angle of 8 degrees. So we can see our 8 degrees marked on our diagram here. Down the hill, 20 meters from the base C, a support wire is attached to the ground at B. If the wire makes an angle of 12 degrees with the hill, calculate 1. The height of the pole H, correct to 2 decimal places, and the length of the pole. Well, what I would see, guys, is if there's a hill at 8 degrees, at any point on the hill, it's going to give me 8 degrees. So you can see I'm drawing a little parallel line here, and this guy here is going to be 8 degrees, which means this is the leap we have to take up here. I'm going to draw another parallel line just up here, and what I'm going to see is by my rule of Z, which we looked over the last day, where I have my alternate angles to these two parallel lines, this line being parallel to this line, this whole angle here would be 20 degrees, which means this whole angle up here would also be 20 degrees. And because we know that this pole here, H, is going to be vertical, that's where we know that we can get our angle here, which is going to be 70 degrees. And if we have 70 and 12 degrees, now I can see that I can work out my angle. Oh, and sorry, we have 20 meters here. So now I can see using the sine rule that I can actually work out these, where I have 70 degrees is opposite my 20 meters, and 12 is opposite my H. So for part 1, we're going to actually use the sine rule here, where we're going to have H over the sine of 12 is equal to 20 over the sine of 70. To get H by itself, I'm going to multiply both sides by sine of 12, which is going to cancel it on the left, which gives me H is equal to 20 sine of 12 all over the sine of 70. So now I can put it into my calculator, where I have H equals fraction button 20 sine 12, again making sure that our calculator is in degrees here, all over sine 70 gives me 4.4251 meters, and it tells me to give it to 2 decimal places, so 4.43 meters. So now looking at part 2, it asks me to find the length of the wire AB. So I'm looking for this side over here, which I'm going to call X. I can see that if he's 12 and he's 70, 70 plus 12 gives me 82. 180 minus 82 gives me 98. So I can see that this side here is 98 degrees, which is opposite my angle X. I know H now is 4.43, so I'm going to use my cosine rule. So I have a squared is equal to b squared plus c squared minus 2bc cos of a. I'm looking for this side, which is opposite the angle 98, so I get x squared is equal to 20 squared plus 4.43 squared minus 2 by 20 by 4.43 cos of 98. So again, now I can type this whole side into my calculator. So I have 20 squared plus 4.43 squared minus 2 by 20 by 4.43 cos of 98, which gives me 444.286. And my last step here to find that missing side is just to square root both sides, and that would give me x is equal to 21.078, which to 2 decimal places I'm going to give us 21.08 meters. So take a second, guys, go back through this, make sure it's added into your notes for example 3, and then we're going to try a few questions. Thanks very much everyone, bye now.